evening is being recorded.
This is empty space. Created from nothing. From one observer's perspective, these are all the quantum logical systems that exist a priori, plus photons in the distribution of the background energy interact, contributing logic. Quantum logic using zero free action as the only rule. All of physics is based on least action. Change in action equals zero. The universe can't get free action from anywhere. At the bottom layer, all actions of zero free action happen not just one way, but every way. And those that can happen in more ways have a higher frequency. And the color shows the energy distribution of the photons coming into the picture. And photons generated in the vacuum are then come out. They're looking from one observer's perspective, generating the world from nothing. First distinction, unfolding the closure sensus. All possible logical systems exist a priori. Those that happen from the distorted perspective of the observer. Globally, all actions cancel. Every action is equal and opposite. Nothing happens. But from a distorted perception, incomplete information of the observer, the world emerges. Now, this vacuum, we can see, has energy. And the current balance of matter and antimatter is -3. This is more of an antimatter than a matter universe. But because every particle is generated with an equal number of generated with its antimatter particle, the creation operator can only create equal and opposite, equal matter and antimatter. If we see an imbalance here, it's probably due to the emergence of randomness from deterministic processes, like in Conway's Game of Life or Wolfram's Rouliad. This is like a Rouliad where only the zero free action events occur. The whole generating the whole Rouliad is impossible. It's too complex. But when we restrict it to zero free action, assuming the universe can't get free action from anywhere, it becomes possible to simulate it computationally. So if you look at the particles that were generated here, and we can see we have a slight imbalance now. We have 5 electrons and 3 positrons. 5 5, it's kind of small, 5 positrons and 3 electrons, imbalance of 2. The net charge is plus 2. Vacuum energy is higher than dark energy. Don't have any black holes. In quantum foam, we have a virtual particle pair of electrons right now. Total of 14 particles now. We have deepest well 0.9998, which is slightly gravitational. It's not flat. And we don't have any molecules or atoms. Okay, let's look here. We can see photons coming through. You can see the balance of matter and antimatter going back to 0, which it probably will, since there's only equal matter and antimatter ultimately. A lot of this go in these folds. We have ZFA closure, green, clock rate, spin up. Well, when you spin up, it's spin up. Okay. It combines in a little blast of energy like this, which then dissipates locally, creating dense matter, dense closures. And clicking on these here, I got a virtual photon. What's this? This is a virtual electron. And I should be able to see some escaping particles. There's a positron out here. Another positron. Lots of positrons, huh? There's an electron. This is all from the vacuum. Given the temperature of the background and the distribution of photons coming from the background. So let's go back to the virtual bang. We'll set the flow rate to 0. And we'll set the harmonic octaves up to 12, which is 12 orders of magnitude. And we'll reset the field. Set the temperature to 0. Reset the field. So this is what's created from nothing. When there's no energy around. And now we find that this is exactly the dark energy value, where this is isolated, when this perspective is isolated in deep space with no incoming energy. And we increase the flow rate and things start happening. You can see stuff happening in the vacuum with nothing else in the universe. This is still in dark energy, the thinnest vacuum there is, the thinnest one possible. These closures are all deterministic in nature. And we can see the causal lines here. I have those turned on, where things interact at a distance because of their entanglements. And we can see we've got on a foam here. We have 4 electrons and 4 virtual electrons and 4 virtual positrons. And if we pause this, hopefully we can find virtual electron. And here's another. So we still have no particles, but let's resume and let's see what happens in the future, given plenty of time. Crank up the flow rate. Let things happen here and see the chaos created deterministically in the thing here in deep space, dark energy creates. Ooh, look at that. Okay, we have 6. We want to pause this. We can see the total energy here changing as virtual pairs are created and then annihilated. Oh, we can see it goes up real big sometimes. We stop it. High rate. We slow it down a little. Too fast. Okay, that's 400 electron masses in virtual particles. But we can see the net free energy is 0 because matter minus the antimatter balance is 0 free action. And this is always true globally. But now we look at the particles we have, and we see that there's a muon, 2 electron positrons, electrons and 2 positrons, and 2 muons and antimuons. Now, if we look here, we should be able to find the particles. Let me turn down the frequencies here. We have 12 octaves. Let's just look here. Now we can see the individual particles. And the most energetic virtual electron, virtual muon, It looks like a bug. So let's go back to the beginning. Flow rate to 0. Temperature's still 0. Field rate. Whoops. Well, let me reload this whole thing. Okay, now I want to again set the temperature to 0, the flow rate to 0, and I want to reset. Okay. Those are the possibilities that we start with. We put up the flow rate again. And I guess what I wanted to show you was that occasionally it'll generate a proton antiproton, and the energy will go way up instantaneously and then go back down almost instantaneously. Now, so we can see that particles aren't generated with 0 vacuum. When we had the normal vacuum energy coming in, eventually particles were created, real particles. Now, if we go back toward the Big Bang and we increase the temperature more, we can see the electrons and positrons being generated now. We can see that we have a lot of electrons and positrons created now, about halfway back to the Big Bang. We don't have any black holes, molecules, or atoms. Now we go higher. You can see electron and muon pairs. But they still tend back to zero because everything is balanced. But we do have an imbalance in matter and antimatter. Keeps changing. Uh, Now we can see we've got four black holes generated. As Einstein initially thought black holes were impossible because he said gazillions of tiny black holes would be created at the Big Bang. And this shows that that it's true. And by crank up to the Planck energy, now we get lots of black holes created. And we get a huge redshift. And we have an atom, we have a couple of atoms that have generated. No molecules yet, but a couple of atoms. 16 black holes. Now, these black holes don't grow, but we can see our atoms here. Hydrogen has a bound proton and electron. And we probably have an anti-hydrogen somewhere, maybe. What do we have? Yep, we have one anti-hydrogen and one hydrogen. And let's really. Now we got 4 atoms. Yeah, we got 0 atoms. And if we can get a few atoms in there, they'll combine into molecules. I don't see anything happening here. One atom, 0. One atom. One. You see all these annihilations happening. Oh, 2 atoms. What do we got? Oh, black hole walking, evaporating. And notice how the photons are now curving and let's turn down the temperature here. Come back to the temperature today, 2.7 Kelvin. Now it's close enough. And resume. And it looks like we didn't catch any surviving atoms here. It's not going to make any more at this temperature. I hope I showed you an atom. We didn't get any molecules this time around. But we have a couple of, we have an imbalance of matter and antimatter. We have one black hole left. Where is it? Let me turn down the harmonic octaves. There's the black hole. Oh, no, that's an electron. See the hot one. I don't see the black hole anywhere. Well, it's somewhere. Spin it around. Maybe black hole can't. Maybe we can't see a black hole in a black background. Oh well. Oh, black hole evaporated. Now I didn't get any atoms in there, but suppose we wanted to put an atom in here. We could put a hydrogen atom in here. There we go. Oh, I didn't. Okay, put the Q calc in here. I have to inject that hydrogen atom in to the diagram. I don't see it. Let me inject another one. Inject another one. Okay, now we got some atoms in here. So what was it? There we go. Now, if we put some more hydrogens in here, we would end up would make H2 molecules, which I guess we can do. Inject some more hydrogen. There's one hydrogen there, and inject another one nearby, and then we can resume, and we get an H2. molecule, one molecule, and two other atoms. And I think that's enough for today. Hope you enjoyed watching the microcosm in such detail, running in a browser without any supercomputer.